All right, 37. First of all, I kind of want to get cosine alone. Okay? So I'm just going to subtract the 3, subtract the 3. So now I get cosine of theta is equal to, well, 7/2 subtracted by 3. So the way I like to look at that is just think of it as 6/2, right? Because that's 3. So if I subtract 6/2 from 7/2, I'm left with 1/2. Yay! All right? It doesn't have to be this easy. This is actually super easy, right? I'd like to show you a really hard one after this, if I could. When we think about cosine, we think about, oh wait, we did this. Didn't I do this with you yesterday on the front? Or 2 days ago? Wait, a week ago with Haley. On the front? Didn't know? I'm confused. But what I like is when we have these, we're talking about these triangles, right? And in this case, we don't need to know what the angle is. I can plug that into my calculator, right? My calculator is going to tell me what that is, right? All I have to do is say cosine inverse of 1/2, and it's going to equal theta. And so if I plug that into my calculator, right? What's it going to come up with? Tell me. Come on, somebody. Be smart. Tell me before I do it. Second cosine.
Hey, slow down. Stop. Don't do it.
Don't do your calculator. Do it in your head.
What?
What?
It's 60.
It's 60. Okay. Like what? Ooh, you're so smart. All right, so theta is equal to 60 degrees. But is it? Is it only 60? And that's when you kind of think about the shape. So here's 60 degrees, right? Or that's actually 45. So here's 16 degrees, right? But remember, cosine is what? Opposite over adjacent, right? Opposite over, no, it's not opposite over adjacent. It's adjacent over hypotenuse, right? Cosine, ca, right? I was teasing you. All right, so adjacent over hypotenuse. So this is the angle we're talking about, right? We're talking about this adjacent side right here. And remember, this is your right angle. So that means this green side is your hypotenuse. So it's going to be this, right, over this. Now, the hypotenuse has to be positive. So even if it were this angle, and this is where I'm getting to, or this angle, that's positive. But what about the lengths? Is this a negative length? And a negative and a positive make a negative. So that means these would be all negative halves. But in a 360, this, right, would be one angle, which is 60 degrees. It's also called your reference angle, right? But the other angle would be 360 minus 60. So yeah, 300, right? So you actually have two angles here, 60 and 300. Okay? See how that works? Pretty simple. Now when I showed it to the other students, I showed them this first and it really confused them. So I'm going to show it to you second and hopefully it won't be as confusing. So it starts here. It goes like this, goes like this, and goes like that, right? And that's cosine curve, right? And if we look at that, this is pi. And this is 2. circle goes, yeah. Okay, so, but what I'm trying to say here is this. This 1/2 is right here, because this is 1, right? So at 1/2, how many times is it going to hit? It's going to hit twice. Once at 60 degrees, and the other time at 300. I think I explained that a little better to you guys since I did this second instead of first.
Yeah, that makes sense. More
Cool.
sense.
A lot more sense? Good. Alright, let's move on to this guy. Continuously. Alright, continuously means, oh my goodness, that's real math. Right? That's PERT. That's interest using real math. Like if you put your money in a bond or in some kind of money market account, and it promised you a certain amount of interest, that means it's going to be a continuously problem. Just like if you take a loan, they're going to be using continuously also,
Wait,
right?
so was this continuously or was it for 9 years?
So it's continuously over a 9-year process, right? So continuously means that we're going to be using the principal, right? Times E raised to the RT, or the rate times time, right? PERT, okay? And so the principal was 8,565, right? E, well, that's just E, okay? And then the rate was 8%. We're going to change that to 0.08, right? And then that's times the time, which is 9 in years, and that's 9 years. Okay? Now, if they would have done monthly or quarterly or stuff like that, then we would have had that other formula. Remember that other formula, which was A times 1 plus R over N raised to the NT. Right? So that's a different formula. That's for quarterly or yearly or bi-yearly or stuff like that. Okay? This one is continuously. Okay? And so, well, that's not too bad. Then we just plug that in our calculator. Right? Okay? So I just hit C and I say, well, that's going to be $8,565 times E. So I got to look for my E. Where's E? There's E. And then I'm going to raise that to 0.08 times 9. It equals, and that's 17,596 and 22 cents. Now, what's the bank gonna give you? Now this says 22, so 0.220 something, right? What's the bank gonna give you? Now, here's the thing. Since you're putting it in the bank only is going to give you, it's going to round down. So it's going to give you 22 cents. But if you were getting a loan, this would round up. No matter, even if that was a 0, it would round up and you would owe 23 cents. They're going to take another penny out of you.
I was
Yeah.
so off.
Messed up, huh?
Yeah, I had 3,000 something.
Wait till you look at your time clock here at Muckleshoot. And you find out they're stealing about a half hour maximum from you every day. I already did the math.
Oh, nice.
Isn't that beautiful?
It's not working for me.
Isn't it if you don't clock out at the exact time you clock in?
Yep. No. No, not no. If you don't clock out at the exact time, period. Not that you clock in. No.
How did you type that in?
I'll talk about that another time. Okay, one more thing. Is it still running? One more thing.
Yeah.
Alright, so in order to do this problem, we want to get these things as 25s. But wait a minute. Does 25 times 25, is that 625? 25 squared, 625? Oh, I think it is. Isn't it? What's 25 times 25? I can't, hun, but what's 25 times 25?
500 something.
625. Okay, so this is perfect. So if this is already ready. This says that 25 to the 2x is equal to 25 squared. Guys, please, I'm still recording. Minus to the 3 minus x, right? And so everybody on the block gets a paper, right? So this is 25 to the 2x is equal to 25 to the 6 minus 2x. Oh, snaps. And so, because this is 25 and 25, we can set these equal. 2x is equal to 6 minus 2x. What do? Add 2x to both sides, right? Plus 2x plus 2x. Well, that's 4x is equal to 6. So how do I solve? Divide by 4, divide by 4. X is equal to 6/4, but 2 goes into 6, 3 times 2 goes into 4 twice, so x is equal to 3/2 or 1 1/2. Woohoo! Okay? So again, we have to make these equal, because if I were to tell you 5 to the x is equal to 5 squared, how much is x?
2.
Yeah! Right? They have to be equal. Same thing here. There you go, peeps.